Good evening. So this is Hassan Ahmed Khan. I'm here to present the final project for GIS application in engineering CVEN 5370 submitted to Dr. Venkatesh Udamari, submitted by me L20607532, and I already submitted the course evaluation. So head on. What we have in final project for question number one, the workflow is we need to perform ordinary kriging using the data we collect in the class, and then we need to select the type of semi-variogram, and then we need to tell how well the linear model fit and how well it performed, and then we need to do some comparison between Kriging model and the global model predictions, and which model does better. We need to do that, and then we need to plot the standard error by Kriging, and then we need to tell that if we do the sampling again, so what's the best area. So let's see some basic libraries for question number one. Pip install pip install pykridge, and then we have OS, pandas, SPD. These are all the libraries we adopted it for question number one. And so what are the steps? First, we set the working directory, then we import field data from CSV file, then we create geodata frame point from CSV file, we create geometry column from lat long columns and set CRS EPS D26915. Then we adopt bounds to do interpolation, extrapolate, and then first get the bounds for Jefferson County to create a grid of a size delta. So then we perform ordinary kriging to identify best variogram model with actual data as demanded by the question. Then so this is the answer. The model that best predicts as compared to major data will be used. Ideally, the data should be split into training and testing sets, with the model trained on the training data and tested on the independent dataset. Alternatively, cross-validation could be used. However, for simplicity, only training error is used here. So then we make a plot bars from error, and the best fit model in our case is the spherical model. I'll give you the graphical present. I will tell in the graphical presentation, and you will see why the spherical model is best. So, and then we perform the ordinary kriging with the best fit spherical model on a grid. Then we do some functioning for theoretical semi-variogram and plot the empirical and theoretical variogram. Then plot the predicted surface on a grid as demanded by the question, standard error, and then we have the data of the counter as an ASC2 grid file. So the result is the model does near the data point but exhibits higher error when there is no data, yellow regions. A few data points near the southeast quadrant will improve predictions. So let's see graphical results over here. As you can see, this is this side, over here the north, and here southeast. Okay, and this is the graphical representation via kriging, and here is the main error. Error profile variogram model. If you see linear model, power model, Gaussian model, exponential model, all have too many errors except for spherical model. So that is why in that question number one we selected a spherical model. So that's it from question number one. Quickly head on towards question number two because we have running short of time. That's why I'm speaking too quickly. So for question number two, workflow is given to us. We need to do the watershed delineation. In my case, I did the Lumberton County because my last name first letter is K. So I got the Lumberton County, Texas, and what I did as provided by the workflow. So let's discuss the basic libraries I adopted in this question two. Install Rasterio, install Whitebox, pip install pipshed, and these are the basic libraries we use for question number two. So here we have what I did. I just set the working directory, bring DEM files. Those are build files. Unfortunately, I couldn't be able to upload these build files because these are too heavy, and so that's why I couldn't be able to do that. So and then make a list of DEM file, then extract data sets from DEM files. Then I do the mosaic output to compute metadata. So mosaic output file is also too heavy, couldn't be able to upload it. Then I plot the raster data. Then I adopt Lumberton and Hardin County to reproject geodata frames to WGS84, and then confirmation of coordinate reference system. Then load geodata frame data and plot it. Then perform masking of data. to get the lowest elevation point above zero, our main task in this question. Then do grid from raster data. After that, fill pits and calculate depression, calculate flow accumulation, then delineate catchment and do clipping of the grid. After delineation, extract river network, then calculate distance to outlet from each cell. Let's see the graphical results. But in this particular question, I don't know why, but when after doing all the programming, I snip tools all the graphs I got, when I rerun the all the cells, so there are too many errors appear over there. I don't know why. So as I'm I'm running short of time, so I just submit it in that way. So, but along with the files, so hopefully when our respected professor do that, so may that work. But there are all the coding and everything is available. So let's see the graphical results we have. This is the raster plot. We got latitude and longitude, so that's how our raster plot look like. And then this is the clip DEM inside Lumberton, Texas, you can see over here. And then this is the DEM with city boundary over here, and it looks like this. And at last we have this, the filled DEM graph. So that's all from question number 2. I'm not so sure if I'm able to complete question number 2 or not, but that's what I have been able to done so far in question number 2. So let's head on towards the question number 3, the last question. Here we need to compare the seasons, the winter and the summer season. We need to download Landsat ARD data. Again, this data is too heavy for me to make a zip and upload it, so I couldn't been able to upload this data, but I upload the coding and what I did. So these are some basic libraries. The new one is to import resampling because we need to do the resampling for winter season. So head on towards what I did. This is my first of all compulsory step, mandatory step, working directory. Then I load summer and winter files along with listing the summer and winter files. Then normalize summer and winter scenes. Then calculate the mean value for both winter and summer scenes. Then calculate a standard deviation. Then same procedure adopt to find the mean values of winter and summer season. And then after that we have to after that we load the data which we have figured out, and then we visualize the scenes, okay, for winter and summer. And then after visualization we have to perform three major tasks. Those are like mentioned below, and those are basically the we need to do the pixel comparison, and two more tasks we did. It's you can find in my coding. So it's the set working files along with resampled one for winter season. Resampling we do for the winter files, and then as required we need to do pixel comparison for summer and resample winters, and now find the different. Oh yeah, that's the second one. That's what I'm talking about, to find the difference in each pixel. And the third one is to compute the statistics. So those are three which I told before. So, and then make a list of storing statistics. So the final result of my question number 3 is the most dynamic index indices is the scene 1 highest average difference 69.28, least dynamic index scene 2 lowest average difference 10.81, greatest spatial variability scene 1 highest variance 2709, and then least spatial variability scene 2 lowest variance 589.98. So here are some graphical results. Summer scene 1, summer scene 2, then summer scene 3, winter scene 1, winter scene 2, and winter scene 3. So that's all what I have learned. I never used coding software before, so this is the beginning of Python, and I have learned first time QGIS in my life. Special thanks to Dr. Venkate Udamari for teaching us this software. It's really a challenging course for me, and I try my best to learn everything in this course, but still I have to learn a lot. So it's been a new and great experience for me to be a part of coding world. I will get more expertise in this field to enhance my coding skills. I don't know if I try my best to keep this video under 10 minutes limit, because this is the criteria set by our professor. So that's all from my side. from the final exam. Thank you for watching and listening this presentation. At last, a special thanks to Dr. Venkate Udamari. Have a great holiday, sir. Bye.